guys, in this video I'm going to show you how to solve simultaneous equations. So all that means is we're going to be working out two unknowns, for example B and C, and we'll be given two linear equations like this. So if you haven't done much on simultaneous equations, I do have another video that you may want to check out first with some easier examples, because in this video we're going to be multiplying one or sometimes both of the equations before we add or subtract the equations together. So anyway, let's have a go. So before we can add or subtract these two equations together to try and eliminate the letters, what we need to do is make sure we either have the same number of B's or the same number of C's. So we want to either have 6B and 6B or 2C and minus 2C. The signs are not too important, but the number has to be the same on both of the letters before we can add or subtract. So the easiest and the quickest way to do it on this one is to multiply that bottom equation by 2. Because if I multiply this, negative C, by the number 2, I get negative 2C. So then I'll have positive 2C and negative 2C, and then I can continue adding or subtracting. So my goal is to make sure the numbers are the same on the letters first. So let's do that. I'm going to multiply everything in that equation by 2. So 2B times 2 is 4B, minus C times 2 is minus 2C, not forgetting the 5, 5 times 2 is 10. So I've multiplied everything in that equation by 2, so I'm just going to cross that one out for the moment. So I'm looking at these two equations here. Now remember, when we add or subtract the equations, we want either the B's to cancel out or the C's to cancel out. That's what we want to happen. Well, if I add that top and that bottom equation together, 2C plus negative 2C is 0, so they cancel each other out. If I subtract those two equations, nothing will cancel. 2C take away negative 2C is the same as 2C plus 2C, which is 4C. We want them to be 0, and the only way these will go to 0 is if we add them together. So we need to add everything in these two equations. So if I look at the B's, I've got 3B plus 4B, which is 7B. Then they disappeared. Now I've got my equal sign. And 18 plus 10 is 28. So now we're just solving a nice linear equation. So the opposite of multiplying by 7 is dividing. Remember to divide by 7 on both sides of the equation. On the left-hand side, well, 7 divided by 7 is just 1, so I'm left with 1B. And on the right-hand side, 28 divided by 7 is 4. So I found my first value. I know that B is equal to 4. Now we have to work out C. So in order to do that, you need to choose one of the original equations. Now it doesn't matter which one. I'm going to choose this one, the one I crossed out, just because there are smaller numbers here, so maybe it's a little bit easier to work with. So write that equation out again. And then we're going to replace the letter B with the number 4, since B is 4. So instead of doing 2 times B, we need to do 2 times 4. Everything else in that equation remains the same. So if I work that out, 2 multiplied by 4 is 8. Everything else is the same. And this one's quite easy to work out. 8 minus something is 5, well that something must be 3. So I've worked out the value of C as well. So we've solved our first example of simultaneous equation. Let me get another one. Okay, so remember, we need to have either the same number of x's or the same number of y's before we can add or subtract the two equations together. So the easiest way to do it on this one is to multiply the bottom equation by 3, because x multiplied by 3 will give me 3x, and so it will look like that one, which is also 3x above. So I'm going to do that. I'm going to multiply every single thing in that equation by 3. So x multiplied by 3 is 3x, 5y times 3 is 15y, and 4 multiplied by 3 is 12. So now I've multiplied that equation by 3, I'm just going to cross it out for the moment. Now, if I add these two equations together, 3x plus 3x is 6x, minus 2y plus 15y is 13y. Nothing cancels out. So there's no point adding these equations together. This time we're going to subtract because 3x minus 3x is 0. Remember, we want it to go to 0 for either the x's or the y's. So I can cross out the x's in this one. Now if I subtract the y values, minus 2y, take away 15y, well that's minus 17y. And over here I've got 5 minus 12, which is minus 7. Okay, so now we just solve this linear equation. So the opposite of multiplying by negative 16 is to divide. So I'm dividing by negative 17 on both sides of the equation. On the left-hand side, where we do the opposite, they just cancel. Since minus 17 divided by minus 17 is just 1, so I'm left with 1y. And on the right-hand side, well, we can't actually divide 7 by 17, so minus 7 divided by minus 17 is just the same as positive 7 over positive 17. Okay, so there's my value of y. Okay, it's a fraction, that's fine. I'm just going to leave it like that. The next step is just the same as before. I need to substitute that into one of the original equations. Now, it doesn't matter which one you choose. I think I'm going to choose, again, the one I crossed out, just because this is only a one single x. The numbers look a bit smaller here and here, so maybe it's a bit easier than the other ones. But like I said, it doesn't matter which one you choose. So, I'm going to write that equation out again. So, x plus 5y equals 4. Now I need to change the y value to this. So everything else stays the same in this equation, but when I get to the y, I need to insert 7 over 17. Okay, but notice everything else stays the same. So let's work this out. X plus 5 multiplied by this fraction, well that just gives me 35 over 17 equals 4. And now I'm just solving the linear equation. So the opposite of adding 35 over 17 is to subtract. Remember, you're just solving the linear equation. Remember to do the opposite and then the same thing on both sides of the equation. Here, 35 over 17 minus itself is just 0, so I'm left with x. And on the right hand side, well, I'm just going to cheat a little bit on this one, and I'm going to put this in the calculator. So you just type in 4 minus that fraction. And the final answer is, well, it's a fraction again, so I'm just going to leave it as 33 over 17. So there we go. So it's exactly the same method, it's just a bit awkward with those fractions, but all the other steps are the same. Okay, on to the next one. Okay, so far we've been quite lucky in that we only needed to multiply one of the equations, and unfortunately we can't get away with that in this question here. We need to multiply both of the equations by a number before we can add or subtract these two, because I can't multiply 2 by a number to get 3. I can't just multiply one of them. So I either want the same number of x's or the same number of y's. It doesn't matter which ones I choose. Remember, there's always going to be more than one way of doing these questions. I'm going to multiply this one by 2 and this one by 3 so that I've got negative 6y on the top and positive 6y underneath. Okay, so my y values will have the same number in front. So a quick way of remembering which numbers to multiply is I'm just multiplying the top equation by that number and the bottom equation by that number. So I'm multiplying by those numbers but just switching them the other way. So let me get multiplying. So the top one, 2x times 2 is 4x. This times 2 is minus 6y, and 3 multiplied by 2 is 6. So there's the first one. Now, underneath, if I multiply all of these by 3, I get 9x plus 6y equals 45. So now I've got my negative 6y and my positive 6y. So now I need to think about whether I'm adding the equations together or am I subtracting them in order to cancel those y terms. Well, if I add them, negative 6y plus 6y is 0, so it must be add. If I subtract them, nothing cancels. So now I need to add everything else in those equations. So for the x terms, 4x plus 9x is 13x. That's disappeared, and now I've got my equals. 6 plus 45 is 51. So I'm solving this linear equation to find x. The opposite of multiplying by 13 is to divide by 13. So my answer is 51 divided by 13. So it's another horrible fraction answer, but that's fine. I'm just going to leave it like that. I can't simplify that fraction, so I'm finished with that one for the moment. Now, we need to find the value of y. So remember, you need to write out one of the original equations again. It doesn't matter which one you choose. Let's choose the top one, just because these are smaller numbers, it looks a little bit easier. So I'm going to write out that equation again. But I need to replace the x value with this fraction, okay? Because that is the value of x. So instead of doing 2 times x, we do 2 multiplied by 51 over 13. So you can write times or you can put brackets. They mean the same thing. They both mean multiply. And everything else stays the same. So if I multiply that fraction by 2, I just get 102 over 13, because you're just timesing the numerator by 2. And now I have to solve this linear equation to find y. So here I've got a positive fraction, so I need to minus that fraction on both sides so that it eliminates on the left-hand side, so that's gone to 0, and I'm left with negative 3y. This part I'm just going to put in the calculator. So I've got 3 minus this fraction. Okay, so I'm doing 3 minus 102 over 13, which gives me negative 63 over 13. So the final step, I need to get rid of this negative 3. So the opposite of multiplying by negative 3 is to divide. So you're just dividing by that number on both sides of the equation. Here, negative 3 divided by itself is just 1, so I'm left with 1y. And on the right-hand side, well, I have to work that out. So I'm doing that fraction, negative 63 over 13, all divided by negative 3. So if we put that in the calculator, we get another fraction. So y is equal to 21 over 13. So we've solved the simultaneous equations. Okay, on to the next one. Okay, so in this example, it's similar to the last one in that I must multiply both of the equations by a number in order to get either the x's the same or the y's the same, okay, before I can add or subtract them. So remember that little trick I taught you? Let's say we want to have the x's the same in this one. So in order to do that, I need to multiply the top equation by this number here, so I'm going to times by 4, and the bottom equation by this number here, so the 3. So I'm timesing by 3. So let me do that, let's work that out. If I times this top equation by 4, I get 12x plus 32y equals 108. So that's the first one. If I multiply this bottom equation by 3, I get 12x plus 9y equals 39. So I've done that one. So now I've got a 12x and a 12x, which we want. We need that in order to be able to eliminate the x's in the next step. So, do we add them or do we subtract them? Well, if I add them, I get 24x. So in this one, it must be subtract, because 12x minus 12x is 0. So we're subtracting everything in these equations. So 32y minus 9y, well that's 23y. And 108 minus 39 is 69. And so to solve this equation, to find y, I need to divide both sides of the equation by 23. So 23 divided by 23 is just 1y. And on the right hand side, I get 3 if I divide those numbers. So y is equal to 3. So we found the first value don't forget to continue the question and work out the next letter. So we need to write out one of the original equations again. It doesn't matter which one I choose. I'm going to choose this one just because it has smaller numbers than the other ones. So let's write that equation out again. So I've got 4x plus 3y equals 13. Now, we need to replace the value of y with the number 3. So up here, instead of having 3 times y, we've now got 3 times 3 instead. So you can put multiply here, or you can put brackets, they mean the same thing. Now I can work this out. Well, 3 times 3 is 9, so I've now got 4x plus 9 equals 13. And I'm just solving the linear equation. So I need to reverse everything around x until x is by itself. The opposite of adding 9 is to subtract. Make sure you do the same thing on both sides of the equation. Here, when you do the opposite, it just cancels to 0, and I'm left with 4x. And on the right-hand side, 13 minus 9 is just 4. Okay, so the final step, divide both sides by 4 to find x. So, x must be equal to 1, because 4 divided by 4 is 1. So, if you're not too good at what I'm doing here, the solving of the linear equations, you might want to practice that first if you're not very confident at solving these equations. I do have another video on solving linear equations that you might want to have a look at. I've got one more question to finish. Okay, so in this last example, again, we're multiplying both of the equations by a number before we can add or subtract them. I'm going to try and get the y is the same in this one. So I'm going to multiply the top equation by 4, okay, so by this number here, and the bottom equation by the number 7. Okay, so these two numbers, but the other way around. Okay, so if I do that, that should give me the same y terms. So for the top equation, if I multiply all of this by 4, I get 20x minus 28y, which is equal to 108. Okay, so there's the first one. Now, if I multiply the bottom equation by 7, I get 21x minus 28y equals 112. Okay, so I've done that one as well. Now, this one looks a little bit harder. It's maybe not quite so obvious whether we're adding or subtracting the equations together. Well, if I add negative 28 to another negative 28, I don't get 0, okay? I get negative 56. But if I subtract them, they go to 0, because negative 28 take away negative 28, so you've got a double minus, is the same as negative 28 plus 28, which is 0. So it's actually subtract. Okay, whenever you get the same number but the same sign, so whether they're plus plus or minus minus, it's always subtract. If the signs are different, then you're adding, but you'll get used to this the more questions you do. So I'm going to subtract everything else in the equations. And something else I want to point out in this question is that we can bend the rules a little bit when we're subtracting simultaneous equations. You're probably used to, when you're subtracting, you always do the top one minus the one underneath. Well, when we're subtracting simultaneous equations, we're allowed to swap it around if we want, and we can do it the other way, and we'll end up with exactly the same answer at the end. So in this one, I'm going to do that. I'm going to do the bottom one minus the top one, just because then I'll get x straight away. If I do it the other way around, I'll get a negative x. Okay, so it looks like the bigger numbers are underneath, so that's why I'm going to do this one minus the one above it. So 21x minus 20x, well that's just 1x. We know they've gone to 0, and here 112 minus 108 is 4. So we've already found x. So actually that was quite an easy one. Alright, so remember the next step is to substitute that into one of the original equations. So let's say we choose this one here, 3x minus 4y. So I'm going to write that out again. And then I need to replace the x value with 4. So instead of writing 3 times x, we've got 3 times 4. but everything else stays the same. Okay, now I can calculate that. Well, 3 times 4 is 12. Everything else stays the same for the moment. I like to show all of my working out. It's harder to make a mistake if you do that. Now we're just solving the linear equation. So the opposite of positive 12 is negative 12. So you're going to subtract 12 on both sides. Here we just get 0 and we're left with negative 4y. And on the right hand side, 16 minus 12 is 4. So the final step, to get rid of this negative 4 that's being multiplied with y, the opposite is to divide. Just remember to do the same thing on both sides of the equation. On the left hand side, when you divide something by itself, you get 1. So we're left with 1y. And on the right hand side, 4 divided by negative 4 is negative 1. So there we go, we've solved our simultaneous equations. So I hope that's clear. Please have a look at my other videos on simultaneous equations. If you're doing extended maths and you have to solve simultaneous equations when one's a linear and one's a quadratic, I've got some on that as well. So that's all from me for today, and goodbye.